So in moment area method, it is important for us to draw our elastic curve. Since yung moment area method relates the elastic curve in the tangent at points as well as the deflection. With respect, of course, sa length ng ating distance between the points. Okay? Okay, so looking at our diagram, itong diagram natin, we have a simply supported beam and naglagay tayo ng concentrated load sa gitna. So pagka drawing natin yung ating elastic curve dyan, ito yung magiging elastic curve natin. So we have this red dot line. So we have the red. Ito, yan yung magiging elastic curve natin. Okay? So dito sa point C, yung distance from the beam, ito yung beam natin, yung distance from the beam to the elastic curve is the deflection at that point. Okay? So pag ito, C, yung distance dyan from the beam papunta dito sa elastic curve natin is the deflection at C.
Teacher. Module.
Excuse me, Miss Jonel. Miss Jonel. Miss Istay Wilma, kindly mute your audio. Okay, again, the distance from the beam to the elastic curve is the deflection at that point. So for example, dito sa may C, yung distance dyan, ito, distance from the beam, papunta dito sa elastic curve, that is the deflection at point C. Okay? So pag may point D kayo dito, ito, that will be the deflection at point D. Okay? So yan yung magiging deflection natin sa my point C. Of course, sa may support, wala tayong deflection sa support, but we have a slope or rotation. Okay? So, yan yung magiging elastic curve natin. The next thing is that we have to know the tangent line. So how to draw the tangent? So we have to draw the tangent to the elastic curve at any point. So for example, dito sa A, mag-drawing ako ng tangent line dito sa A. Okay? So yung drawing kong tangent line, the straight line, yung straight line na green, yan yung magiging tangent at A ko. Okay? So from the beam, pag magro-rotate papunta dito, yan yung magiging rotation natin or slope at that point A. Rotation at A. Okay? So pagka meron ako dito sa point B, pagka nag-tangent ako, nag-drawing ako ng tangent line with respect to point B, yan. Daanan ko yan. Straight line yan. Yung rotation dyan, yan yung magiging slope or the rotation ko at point B. Okay? So ito yung magiging slope and we have deflection. Okay? So we have actually two theorems in the moment area method. Yung unang theorem, yung theta AB represent the tangential deviation of A from the tangent at B, which is actually the deflection at point A in the direction perpendicular to the unreformed axis of the beam from the tangent at point B. This is equal to the moment of the area under the MEI diagram between the points. Pag AB, between points AB. Pag BC yan, between points BC. Okay? So yan yung theorem 1 natin. This represent the slope between these 2 points, A and B. Okay? And then yung theorem 2, yung delta, ito, yung delta, this represents the deflection between these 2 points, A and B. Yung deflection between 2 points, A and B, is equal to the area, the MEI diagram area under that point between AB, so between AB. Okay? So times the location of our centroid. Yung X bar, that is the distance of the location ng centroid natin. Okay? So yan yung dalawang theorem for the moment area method. Okay? So actually, ito yung magiging second theorem natin. Ito, di ba? This is the deflection between 2 points. Deflection between points C and A. Di ba? Ito. Ayan yan. Ganyan yung magiging second theorem natin. Okay? So, the distance from the elastic curve, ito yung elastic curve natin, ito. Yung second theorem natin is the distance from the elastic curve to the tangent line drawn from point A, pag CA. Pag CB naman ito, drawn yung tangent line natin, drawn from point B. Okay? So that is our second moment area theorem. As long as continuous yung ating elastic beam, continuous between 2 points. So no internal hinges pagka continuous. Okay? So pagka may internal hinges kasi, that would cause the elastic curve to actually have an inflection point. Diba? Pag may hinge tayo, may inflection point tayo. Okay? So pag tinitingnan natin itong diagram, we can actually have a triangle here. Ito, triangle. Ayan. And using yung trigonometric function natin, tangent is equal to opposite times over adjacent. Diba? So, yung tangent of theta A mo is equal to delta C plus the distance from the elastic curve to the tangent line drawn from point A, yung delta CA, over the length. Diba? So, ayan yan. However, since we are working on a very small angles, we can assume na yung tangent theta natin is equal or equivalent to the slope or deflection at A. Okay? Since very small angle yung pinag-uusapan natin dito. Kaya yung magiging theta A natin dito sa diagram is equal to delta C plus the delta CA over L. Okay? So yan yung moment area method. So let's take an example for us to understand further yung moment area method. Okay, so we have here an example. We have to determine the slope at C and the deflection at B, assuming our EI is equal to constant. Okay? So let's draw our moment diagram based on the load, shear, and moment relation. Okay? Yun yung gagamitin natin dito sa example. Pero nasa sa inyo kung gusto nyo gamitin yung moment diagram parts. Okay? So solving for since at point A, we have a fixed support, meron tayong pagkakaroon tayo ng reaction and moment. So kindly solve for the reaction at A. So solving for reaction, moment muna. Summation at moment at A is equal to 0, clockwise positive. So we have 30 plus 10 times 12 minus MA is equal to 0. So yung magiging value natin ng MA is equal to, kindly solve for our value of MA. RA minus 10 is equal to 0. So what will be our value for MA? 30 plus 10 times 12?
150, ma'am.
150, ma'am.
So we have
150, ma'am.
kilonewton meter. And for the RA minus 10, we have 10 kilonewton. So mayroon tayong 10 and we have 150 kilonewton meter. Okay, so drawing for our shear diagram. For our shear diagram, RA reaction 10, wala tayong load. So straight line yan. And then at B, meron tayong pababa na 10. So that is our shear diagram. Okay, for our moment diagram, paano naman yung moment diagram natin? Okay, at point A, meron tayong moment na 150. So 150, pababa tayo ng 150. Tapos, papunta sa point C. At point C, we have yung area dito sa shear natin is 10 times 6. Dito yung 10. 10 times 6, that is 60. Okay? So, negative 150 plus 60 is equal to negative 90. So, tataas tayo since positive yung shear natin. So, this is negative 90. Okay? At si meron tayong moment. Okay? Meron tayong moment na clockwise. So clockwise, tataas tayo ng 30. So negative 90, pataas ng 30 is negative 60. Okay? Triangle ito, straight line yan. And then, pagdating dito, yung area dito, yun yung magiging value natin dito. So 60, magzi-zero yung moment natin. So triangle yan since yung shear natin is rectangular. So ganyan yung magiging moment diagram natin. Okay? This is our moment diagram. So pag kinuha natin, ang kinukuha natin sa moment area method is the MEI diagram. So pagka moment yan, i-divide lang natin ng EI yan para maging MEI diagram. Okay? So ito na yung magiging MEI diagram natin. Okay? Okay, so after solving for the moment diagram, we have to draw for the elastic curve of our beam. This is very important in the formulation of your equation. Okay, to solve for the slope and deflection. So pagka nag-drawing tayo ng elastic curve, so say yan yung ating A, yan yung ating B. So A, straight line yan, wala tayong deflection, wala tayong rotation sa A, so straight yan. Tapos, bababa siya dito sa my free end. So, curve yan. Hindi straight yan. Curve. Okay? So, this is A, this is C, this is B. Okay? So, the distance from the beam to the elastic curve is what we call the deflection at that point. So, ito, yan yung magiging deflection natin sa B. Ba? Ito yung elastic curve natin. So the distance from the beam to our elastic curve at that point is the deflection at that point. So ito, distance dito is the deflection at this point. Okay? So pagka andito ka sa C, yung distance dito, yan yung magiging deflection mo sa may C. Okay? At A, since this is a fixed support, zero deflection, zero slope. Okay? So yan yung elastic curve natin. Okay, next, we have to draw for the tangent lines. Okay. The tangent at A, paano yung magiging tangent at A natin? Zero deflection, zero slope. So wala tayong slope, wala tayong rotation sa A. So ang magiging tangent line natin sa A is a straight line. So ito yung magiging tangent at A. Okay? Or the tangent at C, ito yung elastic curve natin sa my point C. Ito yung elastic curve natin sa my point B. So pagka nag-drawing kayo ng tangent line sa B, ayan, joke. Straight line to. Straight line yan. So yan yung magiging tangent at B. And for tangent at C, ito yung elastic curve mo pa sa may point C, dadaan yung tangent mo dito sa may iyong elastic. So straight line. Straight line na tangent to. Dadaan siya sa may elastic curve. Okay? Straight yan na. Straight. So ito yung magiging tangent mo at C. Okay? So yan yung mga tangent natin. Ano yung isang hinahanap natin? Slope at C. Paano natin kunin yung slope at C? So ito, di ba? Ito yung point natin. At this point of our elastic curve, pagka nag-drawing tayo ng straight line dyan, pagka nag-drawing tayo ng straight line dito sa point C, dito sa may elastic curve, yan, straight line, point C. Okay? Ang rotation yan, pag ganon, from our point C, papunta dito sa tangent, yan yung magiging rotation mo ng C. That is actually equal to the theta at CA. Yung rotation between C with respect to tangent at A. Okay? CA. Ito yung magiging rotation mo sa may C. Pagka nag-drawing ka ng straight line dyan, magro-rotate yan, that is your slope at C. Okay? And this is actually equal to our first theorem sa moment area method na theta CA. Okay? Yung deviation, yung tangential deviation of C, point C, yung hinahanap natin from the tangent, from the tangent of A. So, para mas klaro, to. Yan. So, ito, yan yung deflection natin sa may C. Okay? So, pagka nag-drawing tayo dito ng tangent line sa may C. Okay? Pero ito, meron tayong tangent line dito na straight line, tangent at A. Okay? Ang hinahanap natin is the rotation at C. So for the rotation of C, say ito yung point C natin dito sa ating elastic curve. Ito yung elastic curve natin. Ito yung C natin. Okay? Since our A, ito yung A natin, straight line, horizontal, pwedeng ganyan. Straight line din na horizontal. Okay? So yung magiging rotation dito, ito, yung magiging rotation dito, sa may point dito, sa may point C, dito sa may ating elastic curve, that is our slope or the rotation at that point, yung theta C. Okay? And this theta C is actually equal to our first theorem na tangential deviation or the tangential deviation of C, kasi yun yung hinahanap natin, C from the tangent A. Okay? So A, ito yung horizontal natin, kaya mayroon din tayong horizontal dito. Okay? A. So ganyan. So nagets ba? Kaya ito, slope C is equal to the theorem 1 theta C A. And then for B, yung hinahanap natin, deflection of B. So ito, pagka ito yung B, from the beam, papunta dito sa ating elastic curve, yan yung magiging delta B natin. So ang hinahanap natin is the slope at C. Ito yan. and then the deflection at B. So, yan. Okay? So, yung dalawang yan ang hahanapin natin sa problem. Okay? So, let's start for the slope at C. So, paano natin solve yung slope at C? So, slope at C is equal to CA. And theta CA is actually the area of MEI diagram between these 2 points, CA. Okay, so titignan natin yung MEI diagram natin between CA. So ito yung A, ito yung C. So ito yung titignan nating moment MEI diagram. Okay? So i-half natin ito. This is triangle and this is rectangle. Okay? So kunin natin yung area. So anong area dito? To. Anong area natin dito? Okay? So isang rectangle, isang triangle. Okay? So delta C is equal to ilan yan? 90. Hanggang dito is 90, di ba? So 90 times 6 plus itong isang triangle, 1/2 of 6 times 150 minus 90, that is 60. Okay? So ano yung magiging value natin dito? Over EI. So kunin nyo lang yung area dito sa MEI diagram between points A, C. So ano yung magiging slope natin sa may C? Can you solve?
720, ma'am.
Ilan?
720, ma'am.
720. This is in kilonewton meter squared over EI. Okay? So this is actually negative, di ba? Pagka ang sign natin dito, negative, means yung rotation natin dito is from clockwise, yung rotation natin is clockwise from the clockwise from the tangent line A to tangent line C. Okay? So ganyan yung rotation natin pagka meron tayong negative. So for the slope at C, ito na yung magiging value natin. 720 over EI. So pagka may value kayo ng EI, substitute yung value ng EI. However, you have to make sure na yung value ng EI ninyo, yung unit ng value ng EI is the same with the unit above. Okay? So the slope or the rotation at C is in radian. Wala tayong unit dyan. In radian yung magiging unit natin. Okay? So for the deflection at B, paano naman yung deflection at B natin? Paano yung magiging deflection at B natin? So ito, 'di ba? Ito yung magiging deflection at B natin. So pag ito yung magiging deflection of B natin, this is actually equal to the second theorem, 'di ba? Kasi pagka nagtangent ka dito sa B, ito yung tangent line mo. Ito yung tangent line mo sa B, 'di ba? Ito yung tangent line natin sa B. Ito. Distance ng tangent A sa B, yan yung magiging delta BA natin. Yeah? Andito yung tangent, dito yung tangent natin. Okay? So yung deflection of B is equal to the deflection of BA, yung second theorem natin. Okay? The distance from the elastic curve, so yung elastic curve natin sa B, from our tangent to the tangent line drawn from the A. Okay? So, andito yung elastic curve natin sa my point B. So, pag bumaba, andito yung elastic curve natin at andito yung ating tangent A. So, yung distance dito sa elastic curve from our tangent, yun yung magiging delta BA. Kaya that is equal to delta BA. Okay? So, to solve for the delta BA, delta B is equal to delta BA. This is actually equal to the MEI area diagram times the X bar. This is the centroid location. Okay? So yung MEI diagram natin between BA. So pagka tinitignan natin itong MEI diagram natin, ang kinukuha nating moment, hindi lang itong AC, pati ito, yan. Kasi from A to B. So lahat yan, kukunin natin yung area. Okay? So unahin natin ito, say, between BA. Kunin natin yung area. So ilabas ko lang yung 1 EI. Okay? So, yung area natin, say, ito. Yung area natin dito is 1/2 60 times 6. Ilan yun? Tapos, yung centroid natin, papunta dito sa may B. Pupunta tayo dito sa may B. Okay? So, yung centroid dyan, 2/3 of 6 is 4. Okay? So, ito, so 1/2 of 60 times 6 times yung ating X bar is 4. Plus, ano yung i-add natin dito? That is actually negative kasi nasa baba, negative. Plus, the area of the rectangle, that is 90 times 6, 540, and then multiplied by the distance of the centroid. And dito yung centroid, that is 3 from C, so plus 6, so 9 yung centroid natin from B. Okay? So we have 90, negative 90 times 6, that is 540 times, ilan yun? 6, 9. Ito yung distance ng centroid. Plus, yung maliit na triangle doon sa taas, that is 1/2 of 60, that is 150 minus 90. Kaya 60 ito, times 6, times, ano yung magiging centroid natin dito? So, ito, 2/3 of 6 mula dito is 4. Diba? Plus 6, kasi from B tayo, plus 6, that is 10. So, we have 0.5 times 60 times 6 times 10. So, kindly solve for our delta B. Solve for our value. This is over EI. So, kindly solve for our value here.
Negative 3,780 kilonewton meter cube, ma'am.
Negative 3,780.
Yes, ma'am.
Yes, ma'am.
Okay, so we have negative 3,780 kilonewton meter cube over EI. So ito na yung magiging deflection natin sa B. So pagka mayroon kayong value ng EI, you have to substitute the value of EI here. Okay? So I hope na take down notes kayo. Okay, so
Ma'am?
since yes,
Ma'am, in kuwadan sa mo, di ba negative amin data kasi ito di ba bakit? In plus dangay data small triangle. Di ba dapat ke negative amin?
oo,
So
negative lahat.
7,000 plus kuma.
So wag niyo kalimutan negative, negative.
Ma'am,
So,
mga
ilan?
data tensor na.
Ilan?
Whatever. Ma'am, it's 7,380.
So 7,300.
80.
Okay, so we have 7,380. Okay, tama ba? So negative, negative, negative. Negative lahat yan. So you have to add all of that. Okay? Okay, so let's have another example. So the problem says that we have to determine the slope at A, and deflection at C using the moment area method, assuming our EI is constant. Assuming our EI is constant. So first, we have to draw for our moment diagram, yung MEI diagram natin. Okay? So let's again use the relationship of load, shear, and moment to draw for our MEI diagram. So let's kindly compute for the reaction at A. So simply supported, may reaction tayo sa A at may reaction tayo sa B. So kindly compute. So pagka nag-moment tayo sa B is equal to 0. So we have 20 RA minus 330 times 10 minus 20 times 5 is equal to 0. So our RA is equal to ano yung magiging RA natin? RA is equal to 20 kilonewton. Okay? And taking the summation forces vertical, masosolve natin yung RB which is equal to 30 kilonewton. So we have here 30 RB and RA which is 20 kilonewton. Okay? So drawing our shear diagram natin, sa my point A reaction, tataas ng 20. Between point A and C, wala tayong uniform load or any load, so straight line yan. Okay? So 20 minus 30, magne-negative 10. Okay? Straight line din between C and D, wala tayong load. And then negative 10, pababa na 20, so we have negative 30. From between D and B, 0, kaya ganyan. So negative 30. Okay? And this is for the shear diagram. And for the moment, okay. So moment, wala tayong moment sa A. O, pagdating sa may C, ang moment natin is the area of our shear diagram between AC. So anong area natin dito? 20 times 10, that is 200. So straight line, 200. Remember, this is a rectangular, kaya triangular ito, 200. Okay? At C, pupunta tayong D. So pagkapunta mo ng D, ang area ng shear dito is 10 times 5, that is 50. So 200 minus 50, since nasa negative part na tayo, 150. So we have 150. Straight yan triangle, 150. And then this is 30 times 5, 150. So magzi-zero yung moment natin. So remember, yung moment natin, 0. So babalik dapat tayo sa 0. So triangle yan, straight, straight, straight. So this is our moment diagram. Ang kailangan natin, the MEI diagram. So i-divide lang natin ng EI yan. Divide natin ng EI. That is our MEI diagram. Okay? So So let's draw our elastic curve. C, D. A and B. So, ang elastic curve natin, zero deflection dito, zero deflection. So, pag ganyan yan. Okay? Ang hinahanap natin is the slope of A. Okay? So, pagka nag-drawing tayo ng tangent dito sa may elastic curve dito sa may A, tangent, this is tangent line A. Ang magiging rotation dito is our deflection, slope or the rotation at A. So, ito yung isang hinahanap, slope at A. Ito, theta A. Okay? Ang isang hinahanap natin is the deflection at C. Okay? So, ito, ang deflection natin, sabi natin is the distance between the beam, the original beam, and then yung elastic curve. So, ito, at point C, ito yung magiging deflection natin sa may C. So, ito yung pangalawang hinahanap, yung theta C. Okay? Pagka tinitignan natin ito yung tangent, straight yan straight line yan. Yan. Pagka tinitignan natin ito, ang distance between the elastic curve at that point mula sa may tangent line, tangent A, is actually the second theorem, which is the delta C A with respect to the tangent A. Yan yung magiging delta CA mo. Okay? The elastic curve at point C with respect to the tangent at A. Ito yung second theorem natin. Okay? And pagka dito naman sa B, zero yung ating deflection. Kaya mula dito sa may B hanggang dito sa may tangent line dito, tangent line, yan yung magiging delta B A natin. Okay? Distance between the elastic curve at point B with respect to the tangent at A. Delta B A. Okay? Okay, so looking at this diagram, makaka-create ka na ng equation for delta A, diba? Pagka tinitignan mo ito. So itong triangle na ito. Yan. Yan. Using the SOHCAHTOA, theta A is equal to delta BA over the length, which is equal to 10, 5, 5, 20. Diba? So yung magiging theta A mo is over 20. Pagka ito kasi yung kinuha mo dito sa may C, pwede mong kunin ito. Pero pagka ito yung kinuha mo, magiging dalawa na yung unknown mo. Hindi mo alam yung slope sa A, hindi mo din alam yung deflection sa C. Kaya magiging dalawang unknown mo. Okay? So parang ma-solve mo yung slope at A, ang kukunin mo, punta ka dito sa may B, yung delta BA. Okay? What is this? Okay. So, ganyan. So, ito yung magiging equation natin to solve for the slope at A. Ang kailangan lang nating isolve ito, yung delta BA. This is actually the second theorem of our moment area method. Delta BA. So, the moment MEI diagram, area diagram between B and A. So, B, ito yung A. So, kailangan mong kunin lahat yan, yung area ng lahat yan, yung MEI diagram natin, to solve for the delta BA. Okay? So, let's solve first the delta BA. That is equal to the area of MEI diagram times the location of the centroid. Okay? So, unahin natin ito. Itong triangle. Isang triangle yan, tapos yung location niya, that is 2/3 of 5. Ilan yung 2/3 ng 5? Remember, 1/3 ito, 2/3 ito. Papunta sa B, so that is 10/3. Okay? So ito, trapezoid siya, pwede mo siyang hatiin ng isang triangle, isang rectangle. So pagka ito yung rectangle mo, ang location ng centroid dyan is half dito, 2.5 plus 5, 7.5. Okay? Dito, ang okay? So ang magiging location mo dyan, 2/3 of 5 is 10 over 3 plus 5, hanggang dito lang yung 10 over 3 plus 5, that is equal to 25 over 3. So yan yung mga location, yung x bar natin. And lastly, yung isang triangle dito, ang location niya, ayan, 1/3 of 10, 10 over 3 plus 5, 10 plus 10, that is actually equal to 40 over 3. Okay? So balik tayo dito. Unahin natin itong triangle. So 1/2 of 150 times 5 times 10 over 3. So 1/2 of 150 times 5 times 10 over 3 plus itong maliit na triangle dito. So 1/2, 200 minus 150, that is 50. So 1/2 50 times the length 5 times the centroid 25 over 6. So that is 1/2 of 50 times 5 times the location of the centroid is 25 over 3. Plus, yung rectangle, itong isang rectangle dito, that is 150 times 5 times this location of centroid 7.5. So we have 150 times 5 times 7.5. And lastly, yung isang triangle, 1/2 times 200. The distance is 10 times the distance of the centroid is 40 over 3. So kindly solve for the delta PA. Over EI. Huwag niyong kalimutan, this is over EI. So kindly solve for the value of our delta BA. Miss Abay, what would be our value for delta BA? Miss Abay, Angel, anong magiging value ng delta BA natin? Miss Abay, are you there? Wala ito?
Oh, wait lang.
So sino nang may sagot? You can raise your hand. O Mr. Balanso. Roel.
15,520.83, ma'am.
15,000.
520.83, ma'am.
520.83. So did you get the same answer?
No, ma'am.
Ano yung isang sagot mo?
21,250.
21,250. So anong tamang sagot dyan?
21,250 ma'am,
ma'am.
ina-compute ko.
Okay, so answer is equal to 21,250 EI. So that is just the delta BA. Hindi pala yan yung slope na kinukuha natin sa A. Okay? So i-substitute natin dito sa equation yung nakuha natin na value ng delta BA. That is equal to the rotation or slope at A is equal to delta BA over 20. So i-divide natin ito ng 20. Ano yung magiging sagot natin? 21,250 over 20. Sige ka. Ano yung magiging sagot natin? Over EI.
1,062.5 ma'am.
Ilan?
1,062.5.
1,002.5.
Okay, so we have 10,062.5 over EI. So ito na yung
1,000.
magiging value natin for the slope at A or the rotation at A. Okay? So, yung value natin, yung positive, means that the rotation is yung rotation natin, pagka ito yung B, tapos that our rotation is above yung tangent line A natin. Okay? Yung rotation natin is above the tangent line A. Pag ganun yung rotation natin. Ito yung tangent line natin. Above yun sa tangent line. Okay? Clockwise. Above. Meron kasi yung ibang rotation na ito yung tangent. Tapos, ito yung magiging elastic curve. Or sa taas, meron yung iba kasi merong ibang deflection, lalo na pagka may load kang ganyan, tataas yung magiging deflection mo. Okay? So pag ganyan yung magiging tangent mo. So this is negative. Okay? Negative yung rotation niya. Okay? From beam papunta sa tangent, clockwise, that is positive. Okay? That is for the slope and rotation at A. So how about yung isa, deflection at C? Paano kunin yung deflection at C? Okay? Looking at our elastic curve diagram, ito, pag kinuha mo itong triangle na ito, yan. Yan. Kinuha mo yan, masosolve mo yung delta C. Bakit kamo? Na-solve na natin yung slope ng A, which is the 1062.5. Ang hinahanap natin, delta C. Ang problema na lang natin, ito, delta CA, that is the second theorem for the moment area method. Okay? So, kunin natin yan. So, delta A is equal to delta C plus delta CA over yung length, yung buong length nito, that is 10 meter. So, over 10. Okay? So, i-rearrange lang natin yung equation natin. Delta C is equal to 10 theta A minus delta CA. Okay? Ito, yung slope at A natin, that is equal to 1062.5 over EI. Ang kailangan lang natin is the delta CA. So that is the moment MEI area diagram between CA times the location of its centroids. Okay? So, isolve muna natin yung delta CA. So, pagka nagsisolve kayo ng delta CA, yung point CA yung tignan ninyo, CA. Ito lang yung point CA. So, ang kailangan lang natin is the MEI diagram between CA. So, ang MEI diagram lang natin is itong triangle. Kasi yan lang yung MEI diagram between point CA. So, that is 1/2 of 200 times yung distance or the length, that is 10. Diba? Times the location. Ano yung location ng centroid? Location ng centroid from C, hindi sa B. Kanina sa B, ngayon sa C, kasi CA, between C with respect to the tangent of A. Kaya ang magiging location ng centroid natin dito is the 1/3 of 10, that is 10 over 3 ba ang 1/3 of 3? O, tama, 10 over 3, 1/3 of 3. Okay? So delta CA is equal to 1/2 of 200 times the length 10 times the 1/3 of 10. Ito yung centroid over EI. So ano yung magiging value natin dito, CA?
$3,333.33.
Fraction nga muna. Fraction para ano?
10,000
Tayo.
over
3.
10,000
over 3.
over 3 EI. So substituting value here dito sa equation natin, ito yung equation natin, makukuha na natin yung delta C. So kindly solve for the value of delta C. Ano yung magiging value ng delta C natin? So anong magiging value natin? Delta C. So ilan yung value natin dito? We have
7,200.
21,875 over 3 EI. So kindly check, or this is equal to 7291.67.
7.
This is in
When, ma'am?
kilonewton meter cube. So ito na yung magiging deflection natin ng C. Okay? So positive means the deflection is above our tangent sa may A. Ito, above the tangent line A. Okay? Deflection is above the tangent line A. Positive. So that would be now our answer for the problem number 2. So for the slope A and deflection at C. Okay? So do you have any question? Question? Wala? Okay, so kindly try this. Determine the slope and deflection at B. Determine the slope and deflection at B. Okay. So let's say, para mabilis, 90 times 5, this is negative 450 PI. Okay. So this is our MEI diagram. For our So this will be our tangent line A at point A, since this is fixed support. Okay? No deflection, no rotation. Okay? We have to solve for the deflection at B. So for the deflection of B, this is our original beam. Ito yung elastic curve natin. Ito yung magiging deflection at B natin. Okay? So pagka nag-tangent ka dito sa B, ang tangent line mo, ganyan. Ito yung magiging tangent line. Tangent at B. Okay? So pagka nag-tangent line ka dito, ang rotation mo, tangent A, tangent B, ito yung magiging rotation mo sa may B, slope at B. This is actually equal to the theta BA. In between these two tangent A and B. Okay? This is the tangential deviation of B from the tangent A. Okay? Yung theta BA. The tangential deviation of B from the tangent A. Okay? So ito kasi yung point natin dito. Okay? So to solve for the rotation of B, theta B, simple lang yan, di ba? Kunin mo lang yung area ng MEI diagram. So ano yung area ng MEI na diagram natin, Mr. Balong? Paki-dictate nga. Mr. Balong.
Yes, ma'am.
So we have, ano yung magiging MEI area diagram natin dito? Diba? This is the theorem 1 of our moment area. So ano yung magiging value natin dito? So pakibigkas nga, ano yung magiging area natin? Mr. Balong. Andiyan ka ba, Mr. Balong? Wala? Absent ba ito? O Miss Besan? Dito ka ba, Miss Besan? Kindly dictate our MEI diagram, the area, to solve for the area of our MEI diagram between point BA. Wala din. O Miss Bukaw? Andito ba si Miss Bukaw? Okay, anyone? Paki-raise lang yung hand. O Mr. Randolph?
Ma'am, it's negative 1/2 times 450 times 5.
So we have negative 1/2 times 450 times 5. Okay, tama. Ang kukunin natin dyan is the area between A. 10 minutes. Ang kukunin natin is the area between point A and B. Ang area ng between point A and B, ito lang naman na triangle, kaya 1/2 450 times 5. So ang value natin dito is negative 1125 over EI and kilonewton meter square. Okay? So yan yung magiging slope natin sa A. How about our deflection at A? Ano yung deflection natin at A? So the deflection at A, deflection at B. Paano yung deflection at B natin? That is equal to deflection of points between B and A. Okay? B and A. Since andito yung tangent, dito yung tangent ng B. So this is actually equal to delta BA. Okay? So, ang mangyayari dyan, MEI diagram, area diagram between BA times the X bar. So, na-solve na natin yung MEI area diagram of BA, di ba? That is equal to 1125 over EI. Ano yung magiging X bar natin? X bar natin is 2/3 from B. Kasi B, BA. Okay? B with respect sa tangents ng A. So, that is 2/3 of 5. Okay, so 2/3 of 5 is 10 over 3. So kindly solve for the deflection of B. So 1125 times 10 over 3. So that is equal to 3750 over EI in kilonewton meter cube. Okay, so this will be our deflection at B. Okay?